Do you know what's the most important component inside your computer? It's that little tiny thing that you can't see unless you open up your PC. And it's called a CPU, which stands for Central Processing Unit. But what exactly does it do? How does it work? Why do we need it? And how does it make our life easier? Well, I'm here to answer all of those questions and many more. So without further ado, let's get started. I like to think of a CPU as the brain of your computer. Just like our brains, CPUs are responsible for controlling and processing information. In fact, the word processor in CPU actually stands for Central Processing Unit. You know what they say, names are important. And this name really tells us everything we need to know about what a CPU does. Now, it's not the only thing that it does, but it's definitely one of its main tasks. When you turn on your computer, you open a web page or try to run a program, your computer doesn't automatically know what to do. These are just strings of binary code to it. They don't mean anything. The CPU's job is to take these raw codes and process them, making them into something understandable for the rest of the hardware in your computer, like your screen or keyboard. Once the CPU receives instructions from you, it will process them in a specific order, allowing the rest of your hardware to function properly. Now, the reason why CPUs are so important is because they're basically what allows your hardware and software to communicate with each other. Without a CPU, your hardware wouldn't be able to understand what software is trying to tell it to do. The CPU is kind of like the translator in this scenario. So you can think of it as the middleman between your hardware and software. So what exactly happens when you turn on your computer? What is the CPU doing during that time? Well, when you turn on your computer, the CPU starts fetching instructions. Fetching is like grabbing something for someone. So the CPU is going into the memory of your computer and grabbing the instructions that are stored there. After grabbing the instructions, the CPU decodes them. Decoding is like translating a foreign language so that you can understand it. So the CPU is taking the instructions that it grabbed and turning them into a language that it can understand. After decoding the instructions, the CPU sends signals to the other components of your computer, telling them what to do. For example, if you were to open up a web page, the CPU would send signals to your computer's graphics card, telling it to display the web page on your screen. The CPU also sends signals to your computer's memory, telling it to load the web page into your RAM. Finally, the CPU sends signals to your computer's hard drive, telling it to spin up and start reading data from the web page that you requested. The CPU has several different components that all work together to process information. The first component is the control unit, which is like the manager of a team. It's responsible for telling the other components what to do and when to do it. The next component is the arithmetic logic unit, which is responsible for performing arithmetic calculations like addition, subtraction, multiplication, and division. It's also responsible for logical operations like comparing two numbers to see if they're equal or if one is greater than the other. Next, we have the registers, which are like the CPU's memory. They're used to store data that the CPU is using immediately. And finally, we have the cache, which is like a small, very fast hard drive that stores data that the CPU needs to access quickly. CPUs are measured in clock cycles. A clock cycle is the amount of time it takes for a CPU to complete one instruction. Most modern CPUs can execute several billion clock cycles per second. The speed of a CPU is determined by two factors: the number of clock cycles per second and the number of instructions that can be executed in each clock cycle. The more clock cycles per second a CPU has, the faster it will execute tasks. The more instructions that can be executed in each clock cycle, the more work the CPU can get done in a given amount of time. Over the years, CPUs have become smaller and smaller, thanks to the shrinking of transistors. Transistors are the tiny switches that allow CPUs to execute instructions. As transistors have gotten smaller, CPUs have been able to pack more and more of them into a single chip. This has led to an increase in processing power and a decrease in cost. CPUs are constantly being improved. Manufacturers are always looking for ways to make them faster, more efficient, and cheaper. One way that they've done this is by increasing the number of cores that a CPU has. A core is basically a group of transistors that work together to execute instructions. By adding more cores to a CPU, manufacturers are able to increase the amount of work that it can do in a given amount of time. Hopefully, now you have a better understanding of what a CPU does and why it's so important. If you enjoyed this video, make sure to leave a like, subscribe, and hit the bell for notifications. Also, let us know in the comments below what you want to see next. We'll see you guys in the next one.